Okay, this is the circuitry of our scrubber bot that we built in part 1. I'm just going to go ahead and remove the battery and the motors from the PCB board. And I'll set these off to the side. Here's the scouring pad, I think is what they called it. It's just going to be the body of our scrubber bot. The bottom pad is velcroed on, so we can just peel that off. I need to peel it off because I need to drill some holes through the plastic body, and I need to gain access to put some nuts from the standoffs that we'll put on later in the project. So what I want to do first is kind of position the PCB onto the frame or body of the robot, and I'm just going to kind of eyeball it and take a marker, a permanent marker, and mark where the holes are going to go for the standoffs to be. I'm just going to have the board stand off slightly off of the plastic frame of the scouring brush. It doesn't have to be exact or anything like that. I just wanted to kind of center mine a little bit, and I also moved the PCB kind of off center lengthwise of the body because I needed to leave some room for our 9-volt battery that we'll place on here later in the project. If you want to get more exact with your measurements, you can use a ruler if you'd like I'm using here. I'm just going to measure on center from mounting hole to mounting hole on the PCB. Again, it doesn't have to be exact. I just wanted to try to make mine as neat as I could to be presentable for sharing this project to you. Okay, now I got a drill bit here. To be honest, I don't remember what size drill bits I used, but the size, me telling you the size doesn't really matter. It depends on the hole size based on your PCB. I think they're all pretty much the same size, but just get a drill bit size that just fits the standoff, the thread part of the standoff, because you don't want your hole to be too big where you got a lot of play, and you don't want it to be too small where you can't fit the standoff stud through the plastic body of the scouring brush or the bot itself or the robot itself. So just choose the correct drill bit for yourself. It needs to be big enough where the standoff, the threaded part of it, can fit and be snug, but not too loose. Again, not too loose to, not really hold anything. I'm going to use this piece of board here that I had available to me, and I'm just going to use it to protect my work surface so I don't drill down through my desk here. Here's the standoff that I'm using. Again, we're going to place the threaded end through the holes, and it's going to stick out the bottom, and that's where we'll put the nut on for it to keep it secure. Now I'm going to use a slightly larger drill bit in order to countersink the drilled holes. I want the standoff to be inset a little bit more to allow for more of the threaded part to stick through the bottom in order to get a good bite for the nuts to screw on and less likely to come off. So again, I countersunk the hole to allow the brass offset to sit lower in the base and also to allow the threaded end to go through the bottom of the base more. So now I'm just going to screw in the offset, and I'll do that by placing in one of the screws that comes with the offset to allow me to screw it down into the base of the scouring brush. The threaded end of the offset sticks out just past the base enough to get the nut on. So you can see the threaded end of the offset sticks out just past the base, enough to get the nut on. The nut is still a little difficult to get on at this point, so I think it's because the burrs of the hook and loops are in the way. So what I'll do is I'll just remove the offset and then trim the hook and loops around the holes. That way they won't be in the way of the nut itself, and I could hopefully make it easier to place the nut onto the threaded end of the offset that sticks through the base of the scouring brush. So I'm just using these mini snippers, and I'm just going to snip away the hook and loops around the drilled holes. If you don't have any of the mini cutters, you can use these nail clippers. These are my wife's nail clippers. So they work pretty well, but they are a little more difficult to handle because they don't have that silicone handle on them like the mini cutters do. So they're a little bit more slippery, and they also don't have the spring on the handles to spread the handles apart every time you close down on them. So they work, but it's just a little more difficult to use than the mini clippers. You can see that these mini clippers have a spring unlike the nail clippers. It makes cutting quick work. So I didn't have anything on me at the time when I'm filming this, so I ended up using my Leatherman pocket knife, and I used the pliers from the Leatherman to help me tighten the nut on the standoff. Again, we'll just go through the same process as we did with the first standoff, and we're going to do that for the remaining standoffs for our PCB board. Okay, now that I got all the standoffs on the base of the scouring brush for our Scrubberbot, I can now put on the PCB board. Once the PCB board is secure, I can now replace the brush on the scouring brush handle. So now you can see our Scrubberbot is starting to take shape. Now it's time to install the motors on the scouring brush handles. These dimples on the handle are perfect for the motors to sit in. I'm going to use this double-sided sticky tape to help hold the motors in place while I try to secure them to the handle. Now I'll use a zip tie to secure the motor while I drill the holes for the permanent zip ties. Now I'll just drill holes in the handle for where the permanent zip ties will be fed through. Now I'll remove the temporary zip tie. And I'll drill the next hole for the other zip tie. I'll just make sure that these are secured tightly now. Now I just need to put the other motor on, and I'll go through the same process. I'll use the sticky tape to help hold it in place, and then I'll place in the zip ties. Okay, I decided to use one of these medicine bottle caps. It's just your typical prescription bottle medication cap. I'm going to cut it in half, and I'm going to use it as sort of a counterweight for the ends of the motors. And as we go through the process, you'll see more on how this is going to work later. So I'll need to score a line on the plastic before cutting because the plastic is brittle when cutting it. I tried on a previous bottle cap and was just trying to cut it, and the whole thing just shattered to pieces. So I decided on the next one that I'd have to try to do some kind of scoring on it where I wanted to cut it in order to prevent it from breaking apart like the first one did. Okay, now that I got the two halves of the bottle caps, I'm just going to draw some circles where I want the holes to be drilled through them in order to slip them over the motor ends. This one is rubbing a little bit on the handle, so I'll have to trim it just a little in order for it to clear the handle, and it's not going to bang up against it when the motor's running. Okay, now I'm ready to try to secure these halves of the medication bottle caps, and I'm going to use just your typical hot glue to keep them in place. It should hold pretty well. Just be real careful when you're using hot glue because obviously it's hot. Okay, in order to create a little bit more off balance for my plastic medication bottle caps, the halves that I have here, I'm going to place these orange erasers, the eraser ends. I'm going to glue them on each one, and it'll create a little bit more weight offset from the center of the shaft of the motor, and that will hopefully give us a little vibration or enough vibration to move the whole robot. And having two motors on here will, in theory, give us better movement for the Scrubberbot. And that was the whole reasoning behind having two motors and installing the DuPont connectors onto the PCB in order for us to switch around the wires of the motors attached to the PCB board. Not only did the DuPont connectors give us the ability to remove the motors whenever we need to, but we can switch them around in order to change the direction of the spin of the motors. So the reasoning was because it would allow me to do some experimentation on the movement of the Scrubberbot itself and how it reacted based on having the capability of switching the connections of the motors back and forth to try to give me better movement out of the Scrubberbot. And you can try the same thing yourself and experiment more on that if you'd like to. Okay, now I just need to attach our 9-volt battery to the Scrubberbot body. And to do that, I'm just going to use this double-sided sticky tape again. I'll just place it onto the battery and then stick the battery straight to the frame itself. I'm going to need to lightly tighten a zip tie around the motor wires so they don't travel over towards the motors when the motors are spinning and get caught, because that did happen to me one time in testing the Scrubberbot. After I was finished installing the motors and I turned it on, and one of the motors, or not the motor, but the white plastic medication cap got caught in one of the wires to the motor, and it snapped off one of the eraser ends, and it also pulled the wire to the motor off of the PCB board, which then made the motor stop. But it wasn't a big deal. It didn't hurt anything. I just had to re-glue the eraser back to one of the medication bottle caps. So that's why I'm putting the zip tie here, in order to try to attempt to keep the wires from moving around so much and getting too close to the spinning motors. There it goes, it's working. As I said before, we can switch around the wires of the motors to make them spin in opposite directions. Doing so might make the robot change the way that it moves. So we can test this out. So we can test the robot's movement even more by changing the weight on either side of the spinning motors. And the way I'm going to do that is by using a pencil to accomplish this. And what I'll do is I'll just insert a piece of this pencil. I'll have to cut it, but I'll insert a piece of it, and that will allow me to add a little extra weight to one side or the other of the Scrubberbot's motors. I can place that pencil in either eraser end on either side or either motor. That will create kind of a differential in spinning weight between the two different motors. I'll need to extend my mark to be able to pull the pencil out once it's trimmed. I don't want to cut the pencil the exact same length that it fits in there, because then it'll be too difficult to get it out of there. I need to have some kind of grip there to be able to pull it out whenever I need to. So that's why I'm making the second mark on here, to make the pencil sticking into the eraser end a little longer, so I have something to grab onto. First, let's observe the robot's movement without the pencil. Now I'll test the robot with the pencil. So again, here's our Scrubberbot, and let's run some tests. Okay, now I'll switch the red wired motor. I'll just switch its terminals around. You can see that it spins a little differently. Now I'm going to insert the pencil end to this side, and we'll see how differently the Scrubberbot moves. And there you have it. That's our Scrubberbot. I really hope that you enjoyed this project. And remember, keep at it and stay motivated. Thanks for watching.